Okay, so we want to find the average rate of change on the interval from 2 to 5. Now, when we're given an interval like this, what are this 2 and this 5? Is that an x and a y value? Is that a point? Yeah, these would be just x values. So we might say that the 2 is like the x1, and then the 5 is the x2. Those are our two x values. And to find the average slope, we don't just need the x values. But we also need the y values. And to denote the y values, first I'm just going to say, sorry, not f of 5, but g of 5, because my function is g. So g of 5 minus g of 2. So here are my two x values, x2 minus x1, and then these two y values are going to be y2 and y1. Now, to be able to simplify this, of course the bottom, that would give me 3, but what would be on top? Would that be g of 3? What do I need to do first? Yeah, I need to take this 5, plug it into the equation, take this 2, plug it into the equation, and that's going to give us our values on the top. So I know I've got 5 minus 2 on the bottom, which is going to be 3. So let's try to do g of 5, and don't grab your calculator, you don't need it. What's 5 squared? And 25 times 3? Yeah, 75, and then subtract 7 from that. Okay, so g of 5 would be 68. And let's try the same thing for g of 2. So I'm going to plug in 2. What's 2 squared? And 4 times 3, 12 minus 7 is 5. So my two y values are 68 and 5. Then my x values are 5 and 2. So I'm going to subtract the y values on top. I get 63. And on the bottom I get 3. I think that might reduce. Exactly 21. So my slope is 21. Now, let's try to picture that slope. Does that seem like a pretty steep slope? Or a maybe a medium slope? Or a very not steep slope, a gentle slope? That would be a very steep slope, right? If it was a downhill ski course, that would be the double black diamond right there. Very steep. As opposed to the bunny slope. Or the whatever the one in between is. I don't go skiing. Okay. So that's the slope. And 21, now, is it increasing or decreasing? So our function must be increasing because the slope is positive. And we said it seems like it's increasing pretty steeply. So that means every time you go up 21, you rise 21 and then you go over 1. So up 21 over 1, up 21 over 1. That would be a pretty steep slope. It's almost vertical. Okay. So I want you to try with the same function. The average rate of change on the interval -5, -2. So I want you to try that. Different interval this time. And remember, this is telling me which values? Yeah, the x values. So x1 and x2. one favor when you're done. Go ahead and take your phone off your desk. You don't need it. The only thing you can possibly do is distract you. Let's just go ahead and put that away. Sitting right there, face up. Ready to keep you from running mad. That is not. Okay, let's see how you did. Now, on the bottom, where we're subtracting the two x values, we want to be careful with our signs. So a -2 minus a -5, or even if you did it in the other order, it should still work out the same in the end. So the way I wrote it, I've got -2 plus 5, which is a +3. Of course, if you did -5 minus -2, which would be -5 plus 2, you'll get a -3. That's okay, as long as you did the top in the same order. So, g of -2. If I plug -2 into my function, what do I get? 5? That's the same thing I got when I plugged in a +2. That makes sense though, right? Because you just square the negative and it disappears. And then what do I get for g of -5? Okay, the same thing I got for +5. So minus, because we're subtracting the y values, 68. Now, the way I set it up, I'll get a -63 on the top and a +3 on the bottom. If you set it up with the -5 in front and the -2 on the other side, you'd get a +63 on top and a -3 on the bottom. But it's going to work out the same because it reduces to what? -21 is correct. So, what's the difference here? Yeah, this is decreasing. We've got a negative slope. Our function is decreasing. And we might also say that this is a pretty steep slope, -21. So for every unit you go to the right, you go down 21 units. Let's think about this function. So does this answer make sense? What type of symmetry would this function have? Here's a hint. X squared is an even power. Somebody said it. It's got y-axis symmetry, which means any negative x value that you plug in is the same as the positive x value. It's got y-axis symmetry. And so, if we look at the same interval on the right side and the left side, it's the same values, right? These would be mirror reflections of each other. So this function would look something like this. So this interval from -2 to -5 is going to match the interval from +2 to +5. Not drawn to scale. Okay. Well, really, really poorly not drawn to scale. Okay, there we go. So on this side we might have a negative slope. On this side we might have a positive slope, but because it's symmetric, they're going to be the same in magnitude, the same number, the same absolute value, in other words. Same in size. That's what magnitude is. Okay.